Namaste. Again the time has come for self-assessment and here I am with a number of questions to help you in this. Okay, so let's start.
So first question is from JEE Main 2019. The question saying speed is given here. So variation of speed is given. This is v is equal to b root x and motion is along positive x-axis. It is asking for speed of particle at t is equal to tau. Now we have to relate speed with time because here relation is given between v and x. So first we have to get what is relation between v and t and then we can substitute value of t is equal to tau to get velocity or speed at time t is equal to tau. So let us start now. If v is given b root x, so we can write dv by dt as d by dt of b root x. So acceleration will be a is equal to b upon 2 root x dx by dt, or it can be written as b upon 2 root x v. Now if we substitute value of v, then we will get b upon 2 root x and v is given as b root x. So substitute this value here. These two got cancelled. That will give b square upon 2. Now since acceleration is constant, it has value b square by 2. So we can write v is equal to u plus at, right? And value of a already we have given here. So initial speed will be, also it is given that x is equal to 0 at t is equal to 0. So initial speed will be v is equal to b root x when x is 0. That will be equal to 0. Now we got value of u and it can be substituted in the equation v is equal to u plus at to get 0 plus b square by 2, which is value of a, multiplied with time, which is tau. So we got the answer as b square tau upon 2. Which option is this? Option number 2. Move to next question. A ball is thrown upward with an initial velocity v0 from the surface of earth. The motion of ball is affected by a drag force equal to m gamma v square. Here this is the variation of drag force with velocity. So we can write acceleration as, because acceleration has to be force upon mass, so it can be written as gamma v square. We got relation between acceleration and velocity. So net retardation if we write, that will be a net. If we write, it will be equal to, since both g and this retarding acceleration is in downward direction, so it can be written as g plus gamma v square. That is equal to dv upon dt. Here minus sign I have put because these are the values of acceleration in opposite direction. So one minus sign has to be put here. The next step will be dv upon g plus gamma v square, that is equal to minus of dt. Now integrate both sides within the limits. Now it is asking that initial velocity is v0. Now it is given that initial velocity is v0, so initial limit would be v0, and when it reaches to zenith, that is the maximum height. So at maximum height, of course, velocity has to be 0. So this is 0 and time will be from 0 to t. If you now integrate and substitute the limits, that will come as 1 upon root under gamma g tan inverse root gamma v0 upon root g is equal to t. Understood? Here I have used the standard formula for integration of the form 1 upon x square plus a square dx, result of which is 1 by a tan inverse x upon a. So this substitution, it is called substitution method. We have to use this substitution method to get integration of this value. The next question says, in a car race on a straight path, car A takes a time t less than car B at the finish and passes finishing point with a speed v more than that of car B. Both the cars start from rest and travel with constant accelerations a1 and a2. Then v is equal to, it is asking the value of v. So now let us consider car B is taking time t0 plus t. So for B, I am writing time taken if it is equal to t0 plus t. Then for car A, it would be t0 because A is taking time t less than car B. So for car A, it would be t0. The distance between these 2 points, if it starts from some point P to Q, then distance has to be same for both the cars. So let this distance be x. At the end of journey at point Q, velocity of A is, if it has acceleration a1, then that will be equal to a1 t0 because it is moving with constant acceleration and had started from rest. So VA can be written as a1 t0. Whereas VB has to be, here acceleration is a2 and time taken is t0 plus t. Now we can write VA minus VB is equal to, that is equal to V, and it is equal to a1 minus a2, which is the relative acceleration, multiplied with t0 minus a2t. And distance travelled is same. So SB has to be equal to SA. That will be half a1 t0 square, and it has to be equal to for car B also, which is travelling the same speed. So it has to be a2 t plus t0 square. So if we equate these two terms, we will get root under a1 t0 is equal to root under a2 t0 plus t. On solving, t0 will come out as root under a2 t, this divided by root a1 minus root a2. Now if we substitute these values for expression of V, which is, for V we have to write a1 minus a2, this expression I am using, this one. So it is a1 minus a2 multiplied with t0. t0 already we have got the value. Substitute this here, root under a2 t upon root a1 minus root a2 minus a2t. On solving this, answer will come out as root under a1 a2 into t. So this is the final answer. Which option is this? We have to check. This is option number C. The next one is, a particle starts from origin O from rest and moves with a uniform acceleration along the positive x-axis. Identify all figures that correctly represent the motion qualitatively. A is representing acceleration, V velocity, x displacement, and t time. So we have to analyze all the 4 graphs here. One is for acceleration, next one is for velocity, third and fourth both are for position. Okay, so let us start from the first option. Now since particle is starting from rest, so initial velocity has to be 0, right? Also it is moving with uniform acceleration along positive x-axis, so this has to be correct because it is showing that acceleration is positive and it is constant throughout the journey. Now let us analyze the second one. Here velocity is starting from 0, that is correct, and since acceleration is constant, so velocity has to be a straight line. Also acceleration is positive, so velocity must increase linearly with time. Graph B also is correct. Now let us see the third one. Since velocity is increasing with time, so what about x versus t? Now it is saying that it starts from origin. So this third option cannot be correct. Now come to the next one. Here of course x is starting from origin, but let us see about its nature. If acceleration is constant, v has to be a straight line, and if v is a straight line, then x has to be parabola, which we can see is all satisfied in graph number D. So A, B and D, all these three options are correct, which is the option number D here. This again is a graphical question. Two stones are thrown up simultaneously from the edge of a cliff to 40 meter high with initial speed of 10 meter per second and 40 meter per second. Okay, this is from motion along vertical line. Which of the following graph best represents time variation of relative position of the second stone with respect to the first? So here the answer is asking for relative position of second stone with respect to first one. Okay, let us see. Okay, first I am drawing. This is the 240 meter high cliff. From here, one is thrown at 10 meter per second in upward direction. This is 10 meter per second. And other is thrown at 40 meter per second. First we have to find what time these stones will take in reaching the ground. So let us first calculate the times. For first, if it is time taken is t1, then we can write minus 240 is equal to 10 t1. Here I have taken upward direction as positive, downward as negative. Minus half, g is given here, it has to be taken 10 t1 square. On solving, we will get t1 is equal to 8 second. Now let us do this same for second stone. That will be minus 240 is equal to 40 t2. Here time to reach the ground is t2 minus half g t2 square. On solving this, we will get t2 is equal to 12 second. Now if ground is taken as reference, then we have to see what will be position of first stone before 8 second. So let us see y1 if we write. So y1 will be equal to 240 plus, let this be s1, because 240 is already the height reached at its initial point. So this has to be added in the final position. So y1 I have written as 240 plus s1. Now here s1 can be negative as well. So let us see which value comes. So this is equal to 240 and s1 can be written as u1t plus half a1 t square. If we substitute value of a and u1, then it will be 240 plus 10t minus half into 10t square. This is position of first stone after time t, but it should be, this time should be less than 8 second. So this is our first equation. Now let us write the same for second one. So for second stone we can write y2 is equal to, this also had started from the top of cliff, so it has to be 240 plus 40t minus half into 10t square. Now we have to get position of second stone with respect to first. So it will be y21, that is equal to y2 minus y1. If we subtract equation 1 from equation 2, we will get this is equal to 30t, but it has to be only up to time 8 second, because after 8 second particle 1 has reached the ground and its position is now not changing with time. So this will be valid till less than equal to 8 second. So till 8 second the curve has to be a straight line passing through origin. Which option is this? All the 4 options have the same nature till t is equal to 8 second. Which option is this? Option A, B and D have the same nature till t is equal to 8 second. C is not correct because it is saying that up to 12 second this is the nature, which is not true. Now let us see what about after time t is equal to 8 second. So after time t is equal to 8 second, one will come to ground, so its position is now not going to change. So only we will get y21 as y2, and that you can say it has to be a parabolic, because this equation will be there which is a parabolic equation. Which option is correct then? Option number B, which shows after t is equal to 8 second till t is equal to 12 second the graph is parabolic and it is opening up towards negative y direction, which is the direction of g. So second option is correct. Now next question is, displacement of a particle is given with time. X is given as a e to the power minus alpha t plus b e to the power beta t. A, B, alpha and beta are all positive constants and it is asking for velocity of particle. This is very simple because position is given there and we have to calculate the velocity. So simply write velocity will be dx by dt. Differentiate this, that will give d by dt of a into e to the power minus alpha t plus b e to the power beta t plus b e to the power beta t. On differentiation, it will come out as a e to the power minus alpha t multiplied with minus alpha plus b e to the power beta t multiplied with beta. That will give you minus a alpha e to the power minus alpha t plus b beta e to the power beta t. But we have to check how the velocity of particle will vary with time, whether it will decrease with time or be independent of alpha and beta, will drop to 0, will go on increasing. This we have to check. So to check variation in v, let us first calculate acceleration also. So acceleration, if we write, that will be dv by dt. So it has to be differentiated once again. On again differentiating, we will get a alpha square e to the power minus alpha t plus b beta square e to the power beta t. As you can see, acceleration will be positive. All a, alpha, b, beta are positive constants. So acceleration is positive. So velocity will go on increasing with time, which is option number 4. The next question is, a particle is moving along x-axis and acceleration is given by f is given as f naught 1 minus t by capital T, where capital T must be a constant, where f naught and t are constants. It's given here. The particle at t is equal to 0 has 0 velocity. Okay, in the time interval between t is equal to 0 and the instant when f is equal to 0, it is asking for particle's velocity. Let us see when this f will be 0. So let us get the value of time at which f will be 0. So simply substitute it as 0, f naught 1 minus t by t. From here you can see that 1 should be equal to t by t and we got small t is equal to capital T. So at this time acceleration has become 0. We have to calculate velocity in the time interval t is equal to 0 to this value. Now acceleration can be written as dv by dt, or we can say dv is equal to f dt, and then integrate both the sides to check the change. This dv will be, substitute value of f here, that is f naught 1 minus t upon t dt, and it has to be within the limits 0 to capital T, because it is asking when acceleration has become 0 and that time is equal to capital T. So now integrate and put the limits. We will get f naught t minus t square by 2t within the limits 0 to t. On substituting, it will be equal to Vx given as, because at t is equal to 0 it had velocity 0. So and final we can write as Vx. So Vx will be equal to 1 by 2 f naught into t. Which option is this? Option number 4. The next question is not a numerical one. A graph is shown here which is between distance and time, and it is asking the maximum instantaneous velocity of particle will be around the point. Now let us recall what is instantaneous velocity. It has to be ds by dt. So this is ds by dt. What does this mean? Slope of the curve st. So we have to check slope of the curve. It should be maximum because it is asking for maximum instantaneous velocity. So when this curve is maximum, is it at A or B or C or D? As we can see from the graph given here, this is maximum at C. At C, this curve has become very much steeper. So C will be the correct option, which is option number 2. Move to next question now. A bus is moving with a speed of 10 meter per second on a straight road. A scooterist wishes to overtake the bus in 100 seconds. If the bus is at a distance of 1 kilometer from the scooterist, with what speed should the scooterist chase the bus? Okay, so this is something related to relative motion. Now I am writing relative velocity of scooter with respect to bus. How it can be written? Velocity of scooter with respect to bus. I am using the vectorial representation. That will be velocity of scooter minus velocity of bus. This is equal to, for bus it is given, the velocity is provided here, which is 10 meter per second. So it will be Vs minus 10. Now this 10 also must be a vector, so it is in direction of velocity of bus. Here, since we are dealing with 1D motion only, so there is no need to put exactly the vector sign, only plus minus will. This is in direction of velocity of bus. Now what is relative velocity? Relative velocity can be written as relative displacement upon time span. So this will be relative displacement upon time taken. What is relative displacement here? As it is given that initially the distance was 1 kilometer, and since the scooterist want to overtake the bus, so final separation has to be 0. If initial separation is 1 kilometer and final is 0, so what is the relative displacement? That has to be 1 kilometer itself. So it will be value 1000 upon the time taken is 100 second. Substitute this value also here. It will be Vs minus 10. So we got value of Vs as 20 meter per second, which is option number A. One more question is there. A ball is thrown vertically upward. It has a speed of 10 meter per second when it has reached 1/2 of its maximum height. How high does the ball rise? Okay, this is again question from motion in vertical direction. First let me draw the situation if it has started from 0, and let this goes to the maximum height, which I am considering as h, and it is given that half of this height, when this is h by 2, velocity is 10 meter per second. Now let us use the equation v square is equal to u square minus 2gh. Here this is small h, so it can have any value. It is not the maximum height reached. At a, if we write, then this v is equal to 10 meter per second. So it will be 10 square. That is equal to initial velocity. We are not knowing the value. So let us write this as u itself minus 2g. Now g we can write as 10, which is given in question, into h is h by 2 for this point A. So we got the equation number 1. What about the maximum height? At maximum height, let us represent this by b. So at b, velocity has to be 0. It has reached the maximum height. So it is 0. That should be equal to u square minus 2gh, because now the whole height, whole displacement is h. So that will be 2 into 10 into h. Now we can substitute value of u square from one to other. This is our equation number 2. From equation number 2 we can write u square is equal to 20h. Let us substitute this value in equation number 1. That will give 100 is equal to 20h minus these two got cancelled, minus 10h, which is equal to 10h. And from here we got the value h is equal to 10 meter. Which option is this? Option number 2. With this, the chapter 3 is complete, and in next session we will see motion in 2 dimension. So again it is the same kinematics. We have to use the same general expressions, but this time it will be in 2 dimension. So somewhat more complicated as compared to 1 dimensional motion. So let us see forward for the next session. Bye.